All right, let's try and breathe some life into this chapter 3 review. So we're going to graph the two lines and see where they cross. This one is already ready to graph. Starting at 1 with a slope of negative 3 over 1, down 3, 1, 2, 3 over 1, down 3, 1, 2, 3 over 1, up 3, 1, 2, 3, back 1, down 3, 1, 2, 3 over 1. You want lots of dots because you're not really sure where it's going to intersect. Lots of points. Okay, now we're going to graph the other one. This one here, it's not solved for y, so I'm going to subtract over the 2x. So y is equal to negative 2x minus 1. So I'm starting at negative 1 with a slope of negative 2. Down 2 over 1, down 2 over 1. So it intersects right there. Down 2 over 1. So it intersects right there between the two, which is at 2, 1, 2, 3, 4, 5. 2, negative 5. So x is equal to 2, y is equal to negative 5. That's the intersection point. So where the two of them cross. All right, neither one of these is solved for y, so I'm going to solve for y first. Just subtract over the 2x, so y is negative 2x plus 5, so that's that one. So I'm starting at 5. 1, 2, 3, 4, 5, slope of negative 2 over 1, negative 2 over 1, negative 2 over 1, negative 2 over 1, and down like so. The second one is x plus 2y is equal to 1. So I'm going to subtract the x over, 2y is equal to negative x plus 1. Divide everything by 2, y is equal to negative 1/2 x plus 1/2. Now, you can graph this with the slope of negative 1/2 and a y-intercept of positive 1/2 if you're careful, because a half is easy to find. Just go halfway in the middle of the box, that would be a half. Then you go down 1, that'd be halfway in the middle there, and then over 2, and then you go down 1, halfway in the middle there, over 2. So if you're real careful, you can see that it really does intersect right there. So that point is over 1, 2, 3, down 1. So it's 3, negative 1. So x is equal to 3, and y is equal to negative 1. All right, that's the solution for this one. So the deal is you're looking for a point, right, an xy that works in both equations. And you can find that by graphing the two lines and seeing where they intersect, or the other methods. The other methods are substitution and elimination. And we're going to do substitution first here. This one's set up for substitution where we take the x, which is this, and throw it in that x spot. So it's 4 times x is plus 3y is equal to 12. And what is x equal to? 5y minus 20. X position. And we get 20y, because I'm distributing now, minus 80 plus 3y is equal to 12. Put the y's together, that'd be 23y. Add the 80 over, that'd be 92. So we add the 80 over to the other side. So divide by 23, y is equal to 4. Put the y back in to this equation here. 4 times 5 is 20, minus 20, x is 0. So that's the answer to that one. Okay, substitution here. I'm going to, either way, it doesn't really matter. I'm going to subtract over the 4y and get x is equal to negative 4y plus 37. That I'm going to take and put it into the x position there. So it's 8 times x, which is negative 4y plus 37, plus y is equal to 17. Distributing through the parentheses, this times this is negative 32y. For time purposes, that times that is 296, plus y is equal to 17. Put the y's together, you get negative 31y. Subtract over the 296 from the 17, and it'd be negative 279. Divide by the negative 31, and you get 9. So it's 9 for y. A negative divided by negative is positive. Now put the y back in. Negative 4 times 9 is negative 36 plus 37. X is equal to 1. So it's 1 and 9. That would be the intersection point. If you graph the two lines, right? If you graph the first line, graph the second line, that's the solution where it crosses. Elimination, this one is easy because you just add the two equations together. It's already set up for elimination. You get 3x is equal to 9. Divide, x is equal to 3. Put the 3 back in. 3 minus y is equal to negative 4. I call this the back substitution step. So we take the 3, put it back in for x, we solve for y. So we're going to subtract over the 3, so we get negative y is negative 7. Divide by the negative, y is equal to 7. So y is 7 and x is positive 3. Over here, I'm going to make this be opposites by, you can either do two things. You can multiply by 3, and that'd be negative 3y and positive 3y, or you can multiply by 2, and then it would be 4 and then negative 4. So let's multiply by 3 in the first equation. So 3 times the 4 is 12x, 3 times the y is negative 3y, 3 times the 6 is 18. Then we're going to just copy the other equation underneath of it. And you can see I made them opposites of each other. Now we can add the two equations together. And I get 10 cancels out and 30. Therefore, easy, x is 3. We back substitute the x back in either equation. I'll put it in the second equation. Negative 2 times 3 plus 3y is equal to 12. So that would be negative 6 plus 3y is equal to 12. Add the 12 or the 6 over, so 3y would be 18. Divide, y is 6. So 6 and 3 is the intersection point there. All right, that takes care of that. Now these here you can solve any way you want to. You can solve them by elimination or substitution. This one is definitely substitution, because if this equals y and this equals y, then they are the same. So x plus 2 is equal to negative x minus 1. I'm going to add the x over to get it to the same side. That's 2x. So I'm adding x to each side. And then I'm going to subtract the 2 over, and then that would be negative 3. So we divide by 2, and x is equal to negative 3 over 2, which is negative 1.5. So that's okay that it's a fraction or a decimal or whatever. So now I'm going to put that back into the first equation. So my back substitution is y is equal to negative 1.5 plus 2. That means y is a half, or 0.5, however you want to think about it. All right, the next one I'm going to do by a double multiplication here. I'm going to get rid of y. I'm going to make this 3, 6, 9. That goes up to 24, and then 8, 16, 24. So I'm going to make each one of these 24 and negative 24. So that's pretty easy. I'm going to multiply the first equation by 8 times 3 makes 24, and then the next one by 3. So they have no common factors, so you're basically just kind of reversing the numbers there. 8 times 4 is 32 plus x plus 24y is equal to 8 times 24 is 192. And how did I get that so fast? Well, I have my cheat sheet over here. See my cheat sheet? I already knew that was 192. But you can multiply that out. 3 times this is 15x. 3 times this is negative 24y. 3 times this is negative 51. That cancels out when I add them together. That would be 47 is equal to 141. 47x is equal to 141. Divide by the 47. X goes in there exactly 3 times. Okay, back substitute. We're going to put the x back into the equation, and we're going to put it in the first equation. So it's 4 times 3 plus 3y is equal to 24. That's 12 plus 3y is equal to 24. Move the 24 over. 3y is equal to 12. Divide, y is 4. So when you divide that over, you get 4. Okay, this is actually a real problem that I wrote after we were selling tickets for Oklahoma a couple years ago. They sold 40 tickets in all, so X is the student tickets. It's the number of student tickets. So this, at some point when we were selling tickets, this actually really happened. Number of adult tickets. Okay, and I would use S for student tickets and A for adult tickets, but then S's look like 5, so I just use X and Y and then make sure I label what I'm doing here. 44 tickets in all, so X plus Y is 44. And then we do the cost equation. It's $5 for each X plus $10 for each Y is $384 in all. So I'm going to solve this by multiplying everything to get rid of the X. I'm going to multiply this by -5. So -5 times X is -5X, -5 times Y is -5Y, and then -5 times that would be -220. So then copy underneath 385. So this 5y, put those together because we're adding the two equations together, equals 165. Divide by 5, y is equal to 33. So it's 33 adult tickets, and then 33 and 11 make 44, so X is 11 student tickets. So that's the answer to that one. All right, peace out.